You. So, hello everyone. My name is not the easiest one, I think, for Germans, but I think the Spanish and the Paraguayans that are in the room should be able to cope better with my name, the Portuguese one as well. So, Joao is basically John or Johan or Johannes, whatever you want. I'll go for it. We just had a short introduction. I'm going to be talking about the baseline capability, basically how to start something simple to run network-based detection. I have this obligatory who am I? So basically I'm Brazilian, that's why I have this strange name. I'm not a football player, unfortunately. I'm an IT guy. Working for Deutsche Telekom since 2010, based in Nuremberg, actually between Nuremberg and Bonn. I'm doing a lot of network security and network forensics, incident response, collaboration. I like talking to people. That's, I think, one of the great things here from BSides, this open exchange platform that we have. Just like to be able to meet the guys who are really working on related stuff and exchange and get ideas and discuss them, develop them together. It's a great thing. And I love sailing. That's just about myself. Just to set the scenes, 25 minutes, I think that's the biggest challenge of the day. Because I think most of you like this kind of stuff and are also curious persons like I am. But that's the hard part. As a Brazilian, especially because the Brazilians tend to talk too much. So that's why I'll try to keep it to the point. So setting the scenes, this network-based detection. So basically, I'm not the host-based guy. I'm the guy always looking at packets and bits and fields and this kind of stuff. And I'm talking about the baseline capability. That means how to cook your own brew if you want to do some network-based detection. And network-based forensics. On the proposal, I mentioned I would like to bring you some tools and some ideas how to provide you some kind of a stepping stones, really to start doing this, because I think that's a easy. It's not a lot of effort, and you're going to get a lot of it for detecting incidents, and that's the idea. So basically, show you some tools, patterns, and really some tricks to get you started. So that was basically the idea for today. Some introduction and concepts, because I think they are important. When we discuss network-based detection, why is this thing important? In my opinion, and to the best of my knowledge, most of you will already have the assets that are necessary to run this kind of capability. You have switches, you have routers, you have some servers, proxies, and whatever that you can configure them to generate the data you need. So this is going to be, from in terms of investment, not a very big thing, and that's why I think that's important to set it up. If you're running a small or mid-sized environment, it's also not very complicated to get this thing running, to get to talk to operations and convince them that you as a security analyst, a security responder, whatever security, that you need this information to be generated in that device and to be forwarded to some kind of server on your side. And I think comparing this network-based detection and host-based detection, basically, to put it very simple, parallel, I would say firewalls and antivirus. Considering network-based detection, I think typically the efforts to set up a host-based detection capabilities higher than a network-based capability. They complement each other in a certain way, and I think the point here is really, and also maybe a question to you: who on your side is already able to run host-based detection? Who already has some kind of a host-based forensic agent or host-based incident response capability? Like there is a new indicator coming, some kind of a registry key or some kind of a service driver or whatever, file hash. In my opinion, and that's maybe a question of you that would be interesting to see, how many of you already have this kind of capability in your environment? Are you able to run on all your machines to research whether these machines have a certain registry key or certain network device or certain driver or certain configuration on a Windows file? Is this something that you all have, or is this something that we're thinking about it but we don't have it yet? No, no one raises the hand. Oh, one? At least one. Yeah, okay. Two. Great. I also have them. But I think that reflects simply my point. It is not there. And for the network-based detection, these things are already there. So that's why I think that's a low-hanging fruit. That's why that was also the idea behind this presentation. But in the end, I don't like this kind of pictures because they can be easily misinterpreted. But anyway, how those things fit together, and some kind of a very generic process here for doing network-based detection. And that's unavoidable. You have to start by doing some threat modeling. You have to understand what kind of valuable data you have, what kind of attackers are going to be after those data, how does a business works, and what are the things that must be protected, so that you can really understand and start doing your preparation, like to understand, okay, what kind of patterns and can I use to detect breach, to detect attacker activities. What is the tactically relevant data that I need to collect to support this kind of detection? And then you go for the collection. So basically the things that you said, okay, these networks, these kind of protocols are very important in my environment. So I need to start gathering this data. I need to transform it somehow and then consolidate. Basically, I need to filter out stuff which is not important. And again, Iago's presentation, layer 2 frames from a Wi-Fi. I think most likely no one will be looking into those things. That's a covered channel. It's a wonderful one. Similarly to this one, DNS tunneling. I'm going to talk a little bit about DNS tunneling later on, how to detect this, at least how to detect anomalies over DNS protocol. That's why. Then you have to consider again, what is my tactically relevant data that I need to collect so that I can detect this kind of attacks here. And in the end, also need to do some archiving from these things, consolidating them, storing them, and destroying the things that you're not allowed to store. And when you have these things running, you start doing your detection, running these patterns against those data that you have. You do some visualization, evaluation on this data to detect problems or to detect maybe weak spots. That's one important thing here, really, to understand, okay, if I'm not collecting the layer 2 frames that I thought, according to my threat modeling, they are not important for my environment. But when someone comes and slaps me on the face, hey, it's important for you, then that's the point here. Document them, put them back there, and start it over. So basically, I think Mike did this analogy of sharpening your knives. That's about it. Just go and sharpen your knife, reevaluate your threat model, and start it over. I think these kind of slides, we can talk hours about this, we can discuss, we can improve, we can expand them, but today I think we can do it later on the offsite. But it's basically something very generic, just to understand how those things fit together. I hope so far it's so good. Or any questions or comments so far? Okay, great. So about data collection, two very important points about data collection that are unavoidable in my opinion. If you don't have the proper data, you won't have visibility. And again, this layer 2 example here. If you're not collecting, you won't be able to detect. There is also another slap on the face, this report from the Swiss defense company, which is actually a fantastic document to learn about attacks, to learn about resourceful actors. I don't like using APTs for that, but resourceful actors, what the investigation and how the awareness. One of the things that there was in this report, I'm not sure if you're familiar with this RUAG company, RUAG. One of the quotations that are reported that are in this document is there's a point that I say we don't know exactly the current or the actual entry point in our networks because and the quotation that they have is, nevertheless the key aspects of the case could not be clarified due to unavailability of log data prior to this period. Basically they had log data until September 2014, but they could not look in the past. So that's why they really, at some point they said, okay, we cannot understand, we cannot have the full picture of the attack because we don't have the data. And that's something to consider. Sometimes management says, nah, we don't have this much, this big server for the log storage that you want. You won't be able to store 6 months of log data. And you say, okay, that's your call, not my call. I'm advising you to store, but if you don't want, look at what happened to those guys. So something to help you as a defender. It's interesting to take a look at this document. Second point, data collection. Sometimes message content is not available. We talked a lot today about HTTPS and encryption, which is a great thing. And in these cases, it's unavoidable, and I think no one should be doing, normally, that's the case that no one should be doing, should be breaking TLS on proxies, whatever. And that's the point. If the content's not available, you go for the metadata. For instance, you can fairly well reconstruct a web session by looking into what kind of requests, the sizes, and what kind of DNS resolution took place until that point. So that is something that could be complemented. Considering network forensics and network-based detection, what kind of artifacts we have typically? I have PCAPs. I just wanted to make sure that because this network load is sometimes kind of a black box for people who are doing web development or related stuff, but not really into this. Basically, there are 3 types of artifacts that are used commonly. Packet captures, that's PCAP. Everywhere you see PCAP in this presentation. I have NetFlow, which is somehow very network bound. So basically, people who never did anything with network, they most likely wouldn't know what's that. That's basically metadata about packets and sessions that run on the network. There is no message content here again. It's just like a IP address, how many packets, how many bytes went to each endpoint, and so on. And log events, basically events that could be security relevant about some kind of network or some kind of system. So that's basically the 3 types of artifacts that you need to work with these things. And I've started focusing on this. Since we're talking about the baseline, I'll start talking to packet capture because in my opinion, that's more technical. That's how you should start. Okay? One first overview about data collection. And I tried to put, some ideas about how to do data collection, what kind of tools are there. And when I say data collection, it can be either traffic-related data or metadata about network traffic. And I think some tools, some examples. Basically, for traffic, what's the artifact? We already discussed it a little bit. So PCAP, data source, basically network taps or network interface cards. Collection tools, what kind of software you need for that. Basically, TCP dump, which is basically the baseline to get these things done. NetFlow exporters, basically the device that can generate NetFlow records. This can be firewalls, this can be switches, routers, and so on. Likely also to be appliance or hardware device configuration. There are some firewalls like PFSense that can generate this kind of records as well. They are very useful for clarifications, for instance, of data exfiltration and so on. This is something very useful. There's a Linux tool that is able also to generate this kind of information from a network interface or from a PCAP. It's very interesting to start playing with it if you never did. And for about logs, I think this is the common place. I think I don't need to explain what is a web server log. The typical case, and talking again about the baseline, you never did it. What you have to do for TCP dump, for instance, considering that you have some kind of interface card, you want to do a full packet capture, you don't want to do any DNS resolution while doing capture, you just, with this kind of switch here, just kind of a ready-made recipe, you're generating for 3,000, basically for 1 hour, that's seconds here, and you're capturing 24 of those captures. You generate 25 files for 1 hour each, and you're naming them with a proper name, with the date and so on. So basically just something ready-made for you to start using if you're not doing this. If you have some pickups laying around, okay, someone is doing traffic capture for you, you're an incident responder, you're getting there, there are already pickups and you need to filter out data. You could use also TCP dump to filter out data just to focus on certain hosts or certain networks that are relevant for a incident investigation. And I'm trying to speed up as much as I can. Data conversion, I think punchline is really T-Shark. T-Shark is a kind of a command line version of Wireshark. And this is kind of a very interesting because T-Shark has the same protocols implemented as Wireshark. So basically this kind of nifty tool will give you all these protocol fields from layer 2, layer 3 until application layer protocol. So it's the way to go to start doing these things. Just an example here, using T-Shark, pointed to some kind of already existing PCAP. I'm not capturing live data from network, but I'm focusing on what kind of DNS traffic is going on here, filtering out some kind of a layer 3 multicast stuff. A similar example, how to inspect HTTP gets that happened in the past. And T-Shark can also output data in JSON format, which is great for Elasticsearch. Some basic detection patterns, and I'm really running up here now. Threat hunting, I think we can skip this because I think this would be pretty straightforward to explain. But anyway, what I call DNS 1, 2, 3, if you're doing DNS-based hunting, there are some pretty cool stuff that you could use to detect, for instance, DNS tunneling. If you want to inspect all the FQDNs, the fully qualified domain names, the host names that appeared on your network or on a traffic capture that you already have, then you could run something like this, which is basically telling me T-Shark to show me what kind of query names like maps.google.com were triggered by endpoints and so on. And I could also look on the entropy of those labels, like everything which is between the dots, to see when I'm doing tunneling, I need to unavoidably have a high entropy on those labels so that I can code data in as many bits as possible. So basically increase the bandwidth of my tunnel. So that's a kind of a ready-made recipe for doing that. Again, the rate of TXT records or the rate of unusual record types could be also a hint for DNS tunneling. Basically, the point here is why should an endpoint be querying for a name server? Because it has already a name server on a network. So that's basically some things that do not happen. Or tunneling typically implies a lot of CNAME or some text records. That's why how you detect those things and do some kind of aggregation. A very simple one actually on a console, but this thing can be aggregated on Elasticsearch and Kibana stack easily if you have the data extracted from T-Shark using JSON, pumping it out on your analysis environment and running the analysis on there. Last one was non-existent domains, which is basically how to detect domain generation algorithm malware. Domain generation algorithm malware will generate a lot of, let's say, non-existing domains, errors. And this way you could aggregate this information and see what kind of endpoints have spikes in these, let's say, bad DNS queries. This way you would be able to spot some DJ-infected hosts on your networks. And that's my point here. I already knew that this would happen. I put the emergency stop. I have still 9 slides, but I think that's it. We can do it on the offsite. Yeah, that's basically the idea. Questions or?
Thank you so much, Joao. That was really good. So, questions. I'm assuming if you don't have any questions, you all know how to detect malicious stuff on your network.
Have you used the Argus on FreeBSD?
The Argus?
Argus server for packet slicing?
I don't know this tool.
They just pick up and it throw up the equivalent of packet flow. But
like NetFlow.
Like NetFlow, but you don't need NetFlow because you can digest any packet.
I mean,
decoding using the same libraries as T-Shark.
Okay.
So in case you don't have metadata,
I mean, this is about tool set. I mean, when we all discuss tools, everyone will have their favorite tools. That's the point.
That is why I have the question.
Okay.
Because I found, don't know if you've seen it, I saw some problem with packets that were using internet frame padding, and they were sending that into padding. T-Shark was not seeing it, Wireshark was not seeing it, but Argus was flagging this stuff, so it's fine.
Yeah, interesting. I mean,
Yeah, definitely.
yeah, for sure. Yeah. Hey, thanks for the hint.
Thank you for answering.
Cool. Any other questions? What about, you talked a little bit about DNS. What about using like passive DNS?
I think passive DNS is very important to, especially for threat intelligence, to understand what happened in the past. If you're seeing some kind of DNS resolution in a network, and you see, okay, is this new? But this IP address and this domain name, this FQDN combination that you're seeing,
Yeah.
What happened in the past?
Yeah.
I think that's something very strategical, and to understand, I think Farside and
they're a good supplier of historical passive DNS.
They have I mean, everyone doing passive DNS in their environments, it has this great capability of being able to look in the past. Like if I see a combination of if I see a new IP address or FQDN, I can go in back, I can look into this database and see, okay, but how was this IP address used in the past?
Yes.
Like if, that's the thing, the point.
And in this RUA report that you mentioned at the beginning, I know they recommended it as well. And that they would, you know.
Actually, by the way, in this report there are great recommendations
I've
on
read
how to
it.
secure
Really, I
networks.
would definitely recommend it as well. It's very, very good.
So it's a great
Shows
thing,
you how, you know, sophisticated
key
every little
learnings,
detail.
Yeah. Actually, that's a great document, and we all would be able to progress much faster if there were several of those things coming up.
Yeah.
Reports about incidents, things that we learned during hard times,
Yeah.
and it serves the community
Definitely.
fantastically.
So the RUA was breached, and then the Swiss CERT wrote up a 30-page report going into the details of how the breach, took place and how. Well, they don't know the details of the exfiltration, but the fact that data was exfiltrated and everything they knew, including the indicators that could be used by other organizations, were included in the report. That was good. Thank you so much.
Thank you very much.
Yeah.
Thank you, everyone.